Alright, hello and welcome. My name is Nick Brabender and I'm going to be walking you through an FE style exam problem here related to internal rate of return. And before we get started, I just wanted to point out that the internal rate of return is actually going to be what's going to determine the overall quality of our investment. Ideally, the higher the rate, the overall better the investment it would be for us. So, with that being said, let's go ahead and jump right into our problem statement. And our statement reads, you purchased a lot for building your house 4 years ago for $20,000. Each year you paid $220 in property taxes. Each year you spent $80 in maintaining the lot. Now you are selling the lot and will get $25,000 after deducting selling expense. What is the rate of return you receive on your investment? Assume the interest is compounded annually. So in order to begin here, let's go ahead and start drawing out our cash flow diagram. And we can see our initial investment here is of $20,000. We can draw that in there. And then each year we spend $220 in property taxes and then another $80 in maintaining the lot for a total of 4 years. So we can draw this in here as well. So a total of $300 for 4 years. And then finally, at the end of that 4-year time, we're going to be selling the lot and we receive an income of $25,000 here. So we can write that in there. Now, just to point this out, now what we're going to be searching for is our rate of return. And the rate of return is actually going to be the discount rate, which all of our payments and income are actually make it equal to our initial investment of $20,000. Now, in order to do that, we need to break down all of our payments and income into its present value. So for a recurring payment over a period, we have the equation A, which is actually our $300 in this case, times our 1 plus I to the n, which is the number of years. In this case, it's annually for 4 years, minus 1 over I times 1 plus I to the n. And then we also need to reduce our, or bring up our $25,000 to our present value, which would be, equation would be F over 1 plus I to the n. And this is just for the one-time payment where our $25,000 is equal to F. Now, we can set that equal to our initial cost, which is P, which is our $20,000 listed there. After going ahead and putting in our numbers, we have a negative $300 here since it is a payment. 1 plus I to the 4th, which is our number of years. I times 1 plus I to the 4th again. All that added with our $25,000 over 1 plus I to the 4th. Now, well, as you can see, we have I appearing a number of times here in this equation, and that's what we actually need to be solving for. We can do that a few different ways. One would be algebraically. Another way would be to go ahead and plug it into our calculator in an equation solver and solve for I. And if we do that, we get I to come out to be 4%. Now, if we didn't want to use the calculator, we can go back in. There's another way to do it and kind of guess our way through this. We can say that, all right, let's guess around maybe 5% is our discount rate here, and go ahead and plug 5% into all of these I terms. And we'll find out when we do all the math that it actually be a little bit higher than $20,000. So that means we obviously guessed a little high. So what we can do is go back in, make another guess a little bit lower, maybe 4.5%, see that we're getting a little closer to the $20,000, and then try again a guess and maybe go for the 4% and see that it's right about on with the $20,000. So I hope you enjoyed this video. Hopefully it was very helpful, and thank you very much.